You see problem 3, force acceleration 1. The drum has a weight of 20 pounds and the radius of gyration about the center of mass is 0.8 feet. So that basically we have kg equal to 0.8 feet. And then if the block has a weight of 12 pounds, and the question is determine the angular acceleration alpha d of the drum if the blocks is allowed to fall freely. And then the second part is compare this value of alpha d with that determined by removing the block and applying a force of 12 pounds to the end. So instead of block, the 12 pounds force hook to the cord and see whether the alpha d is different. And if it yes, what is that new alpha d? And also explain the reason for the difference. So for the second part, we will discuss that in the next video. But now we only just want to focus on determine the alpha d with this setting, the drum and block. So basically two body. So keep that in mind. It always, the first we need to classify the motion. So classify motion. So for this one, as you can see, we have two bodies. So the first one is drum. We have drum. So rotate about the axis perpendicular to string and go through A. So you will have that in Rafa. Rotation about fixed axis. Block is basically translating in the vertical axis. So it will be translation. And the next step, we want to find out the properties given based on the information given in the problem. So that is properties. And I suggest you always to do that to make sure we know what is given, what is not given. So as you can see, for the drum, it's 20 pounds. That is the weight. So from that, you can have the MD equal to the mass equal to 20 divided by 32.2 feet per second square. So we have it 0.621 slug. And then we also have the radius of gyration, kg equal to 0.8 feet. What does that mean? We will have I, mass moment of inertia, about the axis perpendicular to the board, to screen, and go to the mass center, in this case A, mass center A of the drum. And that one equal to mk square, mk, g in this case, g, ka, right? A or g, the same, because that also at the center of mass now G, now A. So from that we can have 0.621 times 0.8 square. And keep in mind, when they give you a radius of gyration, you don't need to go to the standard set thin disk or things like that to get the mass moment of inertia, but use mk square. So ma here it equal to 0.397 slug feet square. And then we also have the mass, the weight of the block, and then we can find the mass, right? The weight of block equal to 12 pounds. So from that we can have the mass of the block equal to 12 divided by 32.2. So you will get 0.373 slug. So that's what we have for the properties. And then go ahead to draw diagram. Free body diagram equal to kinetics diagram. So let's talk about diagrams. here, and we have two body here, so you will draw each body 2 and then make them equal. Keep that in mind. So drum and the blocks, each of them you wrap 2 bodies. So let's see, the first body we're talking about is the block. So 1 block, then now draw 2 block equal to block. So free body diagram equal to kinetic diagram. So basically, what does that mean? We have FBD, free body diagram, equal to kinetic diagram for block. And then for the drum, you also the same free body diagram equal to kinetic diagram. So what does that mean? In here, a Rafa body, so we can have drum, a Rafa body equal to drum, drum equal to drum, block equal to block. So keep that in mind when you do in this. And then go ahead to draw free body diagram in the left, and then kinetic diagram to the right. So let's start with block. You see the weight 12 pounds, so it will be going down 12 pounds. And this body in translation, and the tension of the cable, it will be T. In statics, you put that equal to 12 pounds, but you see dynamics, don't put that, T unknowns. So here, and the body, of course, B, as you can see, it tend to freely to fall, so it's going down. So you have 3 terms in kinetic diagram, MATX, no, because it goes vertically, MATY, yes, so because that translate in the y direction, so you will have MATY, so in that case, it will be 0.373 AGY, MATX, no, translation, no IG alpha, so that only 1 term in block. Now drum, free body diagram. A is pins, rotate about pins. So pins, it will have 2 unknown, AX and AY. Keep that in mind. So let's talk about here X and Y. X and Y. So we have at A that also the center of mass. Also the center of mass. So you will have in the free body diagram, we have AY and we have AX. And then we also have the tension. We isolate that drum. Then you have a tension in going down on this side, T. And should be the same tension on the block because that is the same cable. And the dimension here equal to 1.5 feet. And you also have the weight of the drum going down, and in that case it is 20 pounds. 20 pounds. So that's all we have for the free body diagram for drum. Now for the kinetic diagrams, you have MATX, MATY, IG alpha. MATX, all about the center of mass. Center of mass here at A. Keep that in mind. This is the center of mass at A. Center of mass at A. So, and A is a fixed point. It's not moving. So you don't have MATX. Not move up or down. So you don't have MATY. But it body rotate. And in this case, clockwise. Because the block B freely rotate down. So as you can see, you only have 1 term on this kinetic diagram, which is IG alpha. G alpha, and that equal to 0.397. We already have slugfish square, so we have 0.397 alpha. So that's what you have in the free body diagram equal to kinetic diagram. So bottom line, count how many blocks. Each block draw 2, make them equal. One side free body diagram, the other side kinetic diagrams. In kinetic diagram, maximum 3 unknowns. How to draw that? Go back to problem 1 when we draw multiple kinetic diagrams. So let's write equation side by side. So in the blocks, you can have the only equation in the y direction that meaningful. So if you have sum of all the force, of course you can do x and y, but nothing x or moment, but nothing in there, only y direction that meaningful. And let's assume it going down equal to ma gy, and then from that we can have fy. So you have it going down, so we have 12 minus t equal to magy 0.373 agy. So let's name that equation 1 for now, equation 1. And you also have x, but nothing, right? 0 equals 0. And translation, no moment. So that only equation for the block. And now for the drum, now you have 3 equations. So let's write down that equation for block. And here we have equation for drum. So sum of all the force in x direction equal to magx. So from that we can have x, in this case it's only ax. magx, look at the kinetic diagram, no agx, so no magx, because a is a fixed point, so it will be 0. So you have ax equals 0. So the reaction in x direction at a equals 0. Sum of all the force in y direction, assume going up, equal to magy. From that, we can have in free body diagram, we can have ay minus the weight 20 minus t equal to magy. And in this case, aay, a is fixed point, so it will be 0. Let's call that equation is equation 2. Equation ax equals 0 already, so you already find out. You don't need to name that equation. And then you talking about the moment, right? Sum of all the moment and suggestion. Let's take moment about the center of mass. In this case, center of mass here is G, and that's same as A. So about G, but G now is A. So assume, let's assume counterclockwise is positive. Counterclockwise is positive. So what you have here is Ig alpha. So from that we can have about A or about G, Ax 0, Ay 0, 20 pounds 0. So meaningful here is negative, because clockwise, T time the center of mass, it's time the radius, so it's 1.5 feet. And then equal to Ig alpha, so it will be equal to, and we assume counterclockwise, Ig alpha is also clockwise, so you have negative 0.397 alpha. And let's make that equation 3. So now this is a tricky part. Take a look, listen. So you have 3 meaningful equations. Let's count how many unknowns. So don't solve until you have enough equation to solve. That is the bottom line. So let's count it. T, 1 unknown. Agy, 2 unknown. Fx, you already gone, Ax, so we don't need to count that. And then, because that already solved, we don't need to consider that. Ay, so it will be 3. It will be 3. Ay, so you have that is 3. And then T already count. The next in third equation, it will be 4. 4 there. So you have three equation, and four nodes. Three equation, four nodes. So how can we do? Draw another diagram. No more. We have two body, and we already draw it. Assume something. Nothing to assume. Because not this is no friction that you have some slip or no slip. So what we do? This is another keyword that you need to show. Kinematic relationship. Kinematic relationship. So when there is too many unknowns with the limited equations, then talk about the kinematic relationship. Let's look at here. When kinematic relationship, these two bodies are not independent. They move together. So how we relate the kinematics? Basically, velocity, acceleration, etc. displacement between the drum and the block. And you can see they hook at a common point B in here. So B belong to, remember, common point belong to drum, and B also belong to the block, right? Belong to block. So they have the same velocity. So if you recall this one, if that here perpendicular, so what we have AB for drum, it will be equal to alpha R, right? And then alpha R. B belong to the block, then it equal to ATY, because it translation any point on the body equal to the same acceleration for the translation body. So as you can see, AB, you have kinematic relationship right down here. You have AB tangential components. AB tangential components here. So it equal to this is alpha that of this term. So you will have AB equal to alpha R. And then ABT also equal to HEY of the block. So you also have, because that's a common point, right? So you have ABT tangential, it hooked to the block, so it equal to AGY. So from that, these two, I will have AGY equal to alpha R, or AGY alpha in this case equal to 1.5 feet. So it will be 1.5 alpha. And that led equation 4. So you now have 4 equations, 4 unknowns, so we can solve. So with that, we can quickly write the plug 4 into 1, and we have set up 3 equations, right? So let substitute number 4 to 1, and then rewrite 3 equations that you have. 1, 2, 3. 3 equation. 1, 2, 3. So what is that? So as you can see, from that we can have, and we can set up from your calculator for number 1, and you can see equation 1 become 12 minus t equal to 0.373 HEY. Now it's 1.5 alpha, so 1.5 alpha. And then number 2, you will have the same AY minus t equal to 20. And then we also have number 3. Number 3. T 1.5. So you have 1.5 T plus equal to, remove the negative in both sides, so you have it 0.397 alpha. So now that is the 3 equation. So you can set up with your calculator, so solve with the calculator, and you can solve for yours too. So, and that I think by now I expect you can solve 3 equations, true or no, with your calculator. 3 and no is T, A, Y, and alpha. So as you can see, solve to get 3 equation and 3 unknowns. In that case, we have that is T, A, Y, and alpha. So we can have now we can have T equal to 3.85 pounds, and then we have alpha equal to 14.55 radian per second square positive, so it will be clockwise. And then we also have AY equal to 23.9 pounds going up. So from that, as you can see, the answer in this case they ask us is what is the angular acceleration of the term, so that what here should be the answer. And for the next video, I'm going to show you what if the block 12 pounds is removed with really only a force 12 pounds, whether the alpha is changing and how it's changing. With that, move to the next video for this part.